Okay, in this video I'm going to look at how to calculate the electrostatic force acting on a particle in a specific location. Here it says determine the force on particle B, so here's B. This is the particle that we're going to be looking at. And I'm going to use Coulomb's law here to consider the force that results from this pair, and then secondly this pair, and then I will sum those two forces to figure out what the overall force acting on particle B is. So for number one, F equals KQQ over R squared, which is 9 times 10 to the 9. I'll call that charge 1, it doesn't matter. Microcoulombs, UC, means times 10 to the negative 6. So 3 times 10 to the negative 6 coulombs. The charge that we're interested in is negative 5 times 10 to the negative 6 coulombs. I'm not really paying close attention to the sign here. I'm going to kind of ignore that sign. That sign, like any vector, is going to tell me the direction of this force. And instead, when I go to finish this problem, I'm just going to look at particle B, and I'm going to use the basic law of electrostatics, like charges repel, unlike charges attract, to figure out the direction of these forces. So I'm kind of ignoring that sign. I don't really care about it right now. I'm just looking at the magnitude of this. Divided by the distance between them, which will be 0.1 meters, right? Can't use centimeters, that's got to be 0.1 meters. And don't forget to square it. So 9 exponent 9 times 3 exponent negative 6, 5 exponent negative 6, divided by 0.1 squared. And I got 13.5 newtons from that force pair interaction. And now, if I imagine this is where I am, and I'm a negative charge, and this is a positive charge, these are unlike charges, which means they attract, which means this force, this particle is going to get pulled towards this particle, and so this is to the left. Okay, now I'll consider this pairing number 2. Again, F is equal to KQQ over R squared here. K is 9 times 10 to the 9. Q, 5 times 10 to the negative 6. And what's that other one? 6 times 10 to the negative 6. Again, they're both microcoulombs, which means negative 6. And the distance between them, once again, has to be in meters, so that's 0.25 meters squared. So just more calculator work here. 9 exponent 9. Times 5 exponent negative 6 times 6 exponent negative 6 divided by 0.25 squared, and I got 4.32. And again, I'm just going to look at common sense here. This is a negative, and this is a positive, which again means they're unlike, which means this particle is being attracted. So if it went that way for 1, for 2 it's going to go this way, and it's going to attract in there, so that effectively will be right. If I do the total force then, F1 plus F2, I can see that one's acting left and one's acting right. So let's make left our negative direction. So I'm going to make that negative 13.5 newtons plus 4.32 newtons, and I get my total force of negative 9.18 newtons, or 9.18 newtons left. So I find the magnitude of the force, the magnitude of the other force. I use my law of electrostatics to determine the direction, and then I add them as vectors, recognizing that if they're going in separate directions, that actually means subtracting them.